Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you. And I am Raghunandan Sengupta from the IME department, IIT Kanpur, and this is the TQM2 lecture series. Again, as we all know, I do repeat it, but you will understand why I do that and why I mention the lecture number, because it makes easy for you to understand and for me also to basically maintain the continuity. So, this is under the NPTEL MOOC series, and this is lecture number 6. Obviously, and this is the first class for the second week. So, because we will have 5 lectures of each half an hour for 1 week, then another 5 which is 6, 7, 8, 9, 10, and it continues for such 8 weeks. So, we are discussing the concept of interval estimation, and I did discuss the difference between the mean given the population variance is known, not known, and how we can use the Z distribution, T distribution with degrees of freedom reducing by 2, which is m plus n minus 2 is the new degrees of freedom. So, let us continue this. So, now I consider the same set of example which we considered in the last few minutes for the 5th lecture. It was something to do with the difference of the sample, the population mean. So, obviously, they are not known. So, we replace them. Consider that the population variances were known, unknown. First they were known, so hence we use the Z distribution. Then they were unknown and equal. Now we will consider them to be unknown as well as unequal. So again we follow the same procedure. X is distributed normal with a certain mean and certain standard deviation of the variance. We know what are they are. They are mu suffix 1 and sigma square suffix 1. For y it is sigma mu suffix 2, sigma square suffix 2. So, and obviously you will have the concepts that we will use S without the dash in both the cases, because S dash would not be used because the population means respective means are not known. So, once you replace them, you have the same formula. In the initial case you had S suffix p, which is the sample, the pooled sample. Now S square suffix m comma 1 and S square suffix n comma 1 are the respective means. So variances of this sample, which is the square of the standard error. So, you replace them in the formula, the same picture comes out, same formula with just a small change. So, where the similarities are, again on the left hand side, if you see the lower limit is the difference with the sample mean. The T distribution has a minus because it is on the left hand side. You see the suffixes are exactly the same, m plus n minus 2 comma alpha by 2, and this case rather than SP, which is the sample pooled with corresponding factor being multiplied, these would be square root of S square m comma 1 divided by m plus S square suffix n comma 1 divided by comma 2 suffix n. So, these 1 and 2 would basically mean, okay, my mistakes, this should be n. So, obviously, this is n comma 2 and then you solve the problems. So, that would be, if you go on to the right hand side, the upper values of the confidence would be exactly the same with a plus sign before t. Now, I want to find out something to do with this population variances concepts. So, I'll discuss the concept, don't go into the details, but you will see that when we come to the hypothesis testing, we will be able to tackle it much more smoothly and much more efficiently. So, is the confidence interval for sigma 1 square divided by sigma 2 square when both sigma 1 mu1 and mu2 are known. So, if they are known, obviously you will safely use S dashes in both the cases. If they are using S dashes, obviously you will know that you would not have any loss of degrees of freedom for the chi-square. So, it will be chi-square suffix n m and chi-square suffix n for population 1 and population 2 from where you have taken the samples of size m from the 1 and sample of size n from the second. Now, if you have something to do with the ratios of the variances of the population, then the next question coming is that are the population mean values known? We have already discussed they are known, hence we have used chi-square without any loss of degrees of freedom. Now, as they are unknown, obviously you would be using, and very intuitively you would have understood that we are using S without the dashes in both the cases. If you are using S without the dashes in both the cases, you will basically have chi-square with 1 degrees of freedom being lost both for m as well as for n. So, it will be chi square suffix m minus 1 and chi square suffix n minus 1. So, once you do that, you can find out the intervals accordingly. Now, obviously, the F distribution I did mention in the 5th lecture, I did not come to that, I am going to come to that, please have the patience. Now, I will try to go into the hypothesis testing, which is a very important concept, and it will be utilized time and again when you are trying to do some design of experiments. Obviously, the background of the theoretical proofs using the maximum likelihood estimate or general methods of movements and all these things, which I did not discuss because this is not a part and parcel of this course, would be coming up in point estimation and interval estimation concepts. So, but the concepts for hypothesis testing would be follow up from this point and interval estimation, we will utilize that, but first there is a separate concept related to the hypothesis testing which we will try to discuss. So, before considering what are the aspects of hypothesis testing, so I will read few things, it will become clear to you, and I will share 4 different scenarios of the example. So, that will make things much easier for you to appreciate as we proceed. So, before considering what are the aspects of hypothesis testing and the statistical rules for the same, depending on how we formulate a hypothesis, we would like to initiate the discussion of this one topic through few very simple examples. So, what are those examples? Let us go one by one. Example 1, a manufacturer of a particular type of electrical motor has come up with a better horsepower rating motor than its existing competitors and wants to market that. As is the norm for any manufacturing product, a certain warranty life is to be specified by the manufacturer for the new product, and the company under our consideration specifies a warranty life of 1 year instead of 8 months for the all other existing competitor motors which are there in the market. Now, you as an engineer are quite skeptical on hearing that, because none of the motors till now had a warranty life 1 year. So, you want to basically test the validity of the statement which the manufacturer has made. So, this is the background of the problem based on which we will try to discuss hypothesis testing. So, this is example 1. Example 2, the food and beverages company which manufactures jelly and jams bottles sells them in bottles of size 100 grams, 250 grams and half kg sizes, and you are the marketing general manager of that firm. In order to meet the growing demand, market demand for these products, your company has installed a new high productive automatic jelly jam filling machine, but there has been complaints afterwards that on an average the weight of the 100 gram bottles for the jams are never exactly the same, as they have been found to be either more or less than 100 grams. So, obviously, there is complaint and people want to find it out. So, in order to answer this complaint and monitor the productivity of the new machine, the company entrusted you the responsibility to solve the problem, and hence you would like to test whether the weights on an average for the bottles coming out are about 100 grams with some errors. Obviously, there would be errors, or is there significant difference between the weights of the bottle, which may be a major concern from the companies, and obviously people can sue them and there can be litigation cases. Example 3, third example. The traffic flow at the main market road in the city of Amritsar is highest in each day in the morning from 10 hours to 12 hours Indian Standard Time, and you are, as the Commissioner of Police in Amritsar, want to see whether it is really needed to have the road closed to motor cars and commercial vehicles for that part of the day in order to avoid any accidents, which has been reported at a rate of 3 per week with a certain distribution. So, you have to verify the fact, take actions, because if you close the road for motorized traffic, obviously there would be inconvenience for people. If you do not close, there would be accidents. So, you have to take a decisions accordingly. Fourth example, in the city of Guwahati, a new internet service provider has opened its services and is providing high speed internet services and claims the speed of its services are 500 Mbps. You are the resident of the city and you are interested to get a new internet connection, but would like to verify this fact and then take a decision whether you take the connection from this new service provider or basically continue with your existing service provider, because there is a cost involved. So, these are the 4 examples in different perspective. It can be also, say for example, you are a farmer in Andhra Pradesh or a sugarcane manufacturer in Maharashtra, and you want to basically test a new fertilizer, and when you are trying to basically test a new fertilizer, the existing output is given in some metric tons per acre or kilometer square of area, and you want to verify whether the new acreage would be more or less. Based on that, you will basically invest your money in the new fertilizer, or it can be some farming equipment also. So, these are the 4 examples already considered, and the 5th one which I just mentioned verbally. In all these 4 examples discussed above, there are some statement or hypothesis or some words have been mentioned, something has to be verified, nullified, agreed upon, so on and so forth, or to be hypotheses are being mentioned. So, they are basically some statistical statements have been made about one or more unknown characteristics or facts about the population which needs to be verified or refuted. So, when we make a claim about a particular hypothesis, at the same time a complementary hypothesis also crops up, which basically will be the other part. So, if you believe on statement 1, there would be complementary statement 1 would basically would complete the whole scenario, which is basically whole scenario means whatever the different type of scenarios you can have. So, when we make a claim about a particular hypothesis, let me read it again. At the same time, a complementary hypothesis also crops up, such that the original hypothesis is termed as the null hypothesis, which is H suffix not or O or 0, while its complementary or negative counterpart or the opposite hypothesis is the alternative hypothesis, which is given by the symbol H suffix A. So, the problem is to state the validity of H naught versus HA, that is the overall essence, and how you do that, that is what the basic mathematical part would be coming from the concept we have already discussed. How you formulate and understand the problem is basically the real part in hypothesis testing. Now, generally how you do that? For the general implementation of hypothesis testing, we follow the following steps, which are as follows. As the norm in the sampling, we first consider a sample size of size n, pick up sample observations capital X1 to capital X suffix n. So, the 1 and 2 and 3 whatever I am mentioning, as you can see on the slide, are the suffixes. So, obviously, if I pick up a sample size of n and if you pick up the sample size of n, so initially before we find out what are the exact values of those random variables, they would be denoted by capital X suffix 1, capital X suffix 2 and so on and so forth, but obviously the realized values would be different. So, obviously what I predict from hypothesis testing would be different from your case. So, obviously neither you are right or wrong, neither am I right or wrong, because based on the examples or the observations we picked up, our answers are different. So, remember this very carefully, this will become more and more clear as we proceed. Then one sets up a decision rule. What is the decision rule? We are going to come to that. Just understand the steps without going to the actual theoretical concept, based on which one tests and makes a decision and chooses one of the decision, that is one of the hypothesis. One should also remember that the decision rule is a technique for making a decision, and the decision is generally described by a statistic. Statistic is basically the corresponding characteristics which I am getting from the sample. Hence, we have 2 of the outcomes, H naught, which is the null hypothesis, HA, which is the alternate hypothesis. So, there can be 2 cases, either accept H naught and reject HA, or vice versa. So, the words I am using accept, reject technically has to be used in a different framework. I will come to that later, but very simply consider either you are for HA and do not agree with H naught, or vice versa. So, this is the overall general problem scheme. Now, in all these cases when you are doing that, a certain scenario will come up. So, this scenario would basically have 4 cases, and what are the cases? If you read and understand the table where I will spend some time, you will understand. Consider the action which you are taking can be 2 type, either you basically reject H naught or you reject HA. Rejecting H naught obviously means accepting HA and vice versa. So, but I am using the word reject based on the information which you have. You cannot accept until unless you are 100% certain. You can only reject depending on the set of information which you picked up. Now, on the other side there is mother nature, and mother nature's informations would be either H naught is true or HA is true. So, now mark the words true and reject. So, the reject you are doing it because your set of information is only once, based on that you are passing a judgment, and mother nature has all the information based on which it is saying that either H naught is true or HA is true. Now, see the 4 combinations. I would not consider the pink one now. First I will consider the cells which are not colored. If HA is true by mother nature and you reject H naught, which means you are agreeing with HA, so obviously there is no error. On the other hand, if H naught is true and you reject HA, which means you are agreeing with H naught, which means that is also true, there is no loss or there is no so called risk. Now consider the other 2 cells which are along the principal diagonal, so called principal diagonal, and they are colored pink in color. So these are the scenarios. If H naught is true and you reject H naught, there is an error or type 1 which is given by the value alpha. And in the other case, if you basically HA is true and you reject HA, it is basically the error of type 2 which is beta. Now let me give an example in order for you to understand, and then scroll down to explain it in more details. Consider, I will just put the example in the right perspective. You are a bank manager, and as a bank manager you have been given the business that you should give loans. Obviously loans can be there, they can be education loans, housing loans, personal loans, business loans. People are coming in your bank to open fixed deposits. So they have salary accounts, then they are coming for opening the recurring deposits, and there are many things. They have the lockers. So consider that you want to give a loan and you are concentrating on only that, and you have a set of questionnaires for people to answer. Based on the questionnaires, the points which you give, you will basically, you and your team will assign a loan or not assign a loan. So what can be the questionnaires, which is very simple to understand. So whether he or she is a salaried person, what is his or her age, whether the person has a government job or a private job, whether the person is a business or is not a business, whether the person has his own house or does not have a own house, whether the person has any liabilities, does not have any liabilities, whether what is the overall credit rating of the person, or the credit rating of the person is absolutely fantastic. So based on that you have different questionnaires and you give points. Consider the total points is 100. So you have decided if a person gets a score or a set of points of about 50, you will 50 and above, you will give that loan, and if it is 50, below 50, 49 and below, obviously, and consider they are only coming in integers, the sum of the scores, you would not give the loan. But there can be 2 scenarios. There can be a set of persons to whom you should not give the loan, but you are giving the loan. So that is a loss. How it is a loss? Because it is a bad debt, so it is a bad business for you. Another set of persons who are there who should get the loan because they are able to pay the loan, but you deny them the loan. So they are opportunity cost lost. So these type of losses, bad debts or opportunity costs, can be considered as the concept of alpha and beta, which I just discussed. This is a very simple example. Now intuitively, if you see, and when I will come to the diagram, you will see that minimizing both of them at the same time is not possible. Why? I will explain that. So example, let us consider. Consider you have, so the example which I am going to consider and the example which I mentioned are exactly the same, but I gave an example of the bank in order to make you understand very simply. Consider we have the x which is normally distributed with the mean mu and sigma square, where mu is the mean and sigma square is the variance. Mu is unknown, sigma square is known, and suppose it is given as mean as mu and sigma square is 0.25. For the other case, so also we assume that we have 2 competing hypotheses. So this is a more mathematical formulation, that is why I give the example beforehand, but the diagram would make sense to you. So 2 competing hypotheses which are H naught mu being 2 with respect to HA mu being 1. It can be not equal to 2 also, it can be greater than 2, less than 2, whatever it is. And we have to test the efficacy of the hypothesis. Now we consider we pick up a sample of size 10. If you pick up the sample of size 10, obviously the sample mean is given by this formula. So which I will just highlight for this discussion. So this is the sample size. So n sample size can be n, which is 10, 20, 25, 30, whatever it is. Then obviously this would become true, which is the overall sample mean, x bar suffix n being 10 obviously would have a distribution as given with mean as mu and the variance as 0.25 divided by 10. So, once we are aware of the information, we move on further, and suppose that choosing a sample size of 10, we get mu, the mean value comes out to be 1.5. So, we want to basically and definitely we are not interested into accepting H naught, we will reject H naught. But obviously, if you pick up that set of observation 10 in number, your value can be greater than 2. So, obviously, in that case you will accept it, or it is 2, you will basically take a decision accordingly. Now, I will read it, but consider the example here. This is the diagram where I want you all of you to pay special attention. Forget about what are the markings numbers, just concentrate on the normal distribution, the red in color, normal distribution blue in color, the mean values which are vertical dotted lines for the mean for the red distribution, which is the red on the left hand side, where I am placing my left hand, and onto the right hand side, which basically the blue one, and also pay attention on the green vertical line, which is the bold one, which is here. Now, come back to the example which I just discussed. If 50 is the marks or the points, so any person getting less than 50 would be rejected, any person getting more than 50 would basically 50 or more would be accepted for the loan. Now, the value which is hashed onto the right red are the set of persons who should be denied the loan, but they are getting the loan, which is basically a bad debt for you. If you remember, I did mention that. And the hash blue one, which is there on the left hand side, consider is alpha, and the red one is basically beta, is the set of persons. The blue one is the set of persons who should be given the loan, but they are denied the loan, which is the opportunity cost lost. So, now if you consider shifting the green line, like trying to reduce it from 50 to 45 or trying to increase it from 50 to say for example 55, you will see trying to basically minimize both alpha and beta at the same time is not possible. So, what you will try to do is that you will try to basically minimize the sum of alpha and beta, and that is the essence based on which we will try to solve the problem. It in the sense that we will keep beta fixed and try to play that and do our problems with considering alpha, or you can do the other way around, but we will always consider an alpha because that is 1 minus alpha will give you the level of confidence based on which we are trying to do the example. So, in this problem it can be H naught can be greater and left. So, these values of where you have placed H naught and HA are not important for you to understand from the problem perspective, the example which I gave. So, if you understand the example and understand the diagram, it will be much easier for you to solve. The hypothesis could also have been framed in the sense that H naught, which is mu, is greater than 2, and H A, which is mu, for that case is less than 2. Again, you can formulate the problems accordingly and solve them, but the essence of the diagram remains the same. So, choosing any values of alpha, when you choose it, basically that you will try to choose it in such a way that your level of confidence or the values which you are trying to pick is basically optimal. Optimum in the sense that you are able to cover the maximum area considering the level of confidence which you have placed. So, with this, if you understand the examples and pause and think about that, the problems which we did discuss in case of say for example the point estimation, they can be easily picked up from those scenarios and try to basically put up in the case of the hypothesis testing. But only remember, framing the problem perspective from the hypothesis testing is the main task based on which we will try to basically proceed. So, I will come to the general. So, these are not relevant for this problem. I did discuss that, and if you are aware of the problems for the case of the banking manager giving a loan, not giving a loan. So, with that we try to basically solve the problems. Now, this is the first scenario. Suppose we want to test the hypothesis. I will directly come to the hypothesis testing. We want to select the hypothesis as highlighted, which is under H naught mu is equal to mu naught. So, this mu suffix naught is basically under the assumption H naught is true, versus the case when you want to find out an alternative hypothesis for which the mean value is mu suffix a, and we want to test that mu suffix a is less than mu naught. So, in that case you will be concentrating on the distribution onto the left hand side. So, if you consider the distribution on the left hand side, the problem becomes that the overall area to be covered till is 1 minus alpha, area has been covered is alpha, hence you will basically reject or accept H naught based on this. What is that? So, this is what is highlighted here. So, the rule is reject H naught if you are on the left hand side. So, what is the left hand side? That your mean value of the sample is less than mu naught minus Z alpha. Now, remember very important thing, it is not alpha by 2. This I will be repeating time and again, into sigma by square root of n. So, now if you go back to the interval estimation, the problems on of the left confidence was exactly the same. It was x bar n, n was the suffix for the sample size, minus z alpha by 2 into sigma by square root of n. So, because it is only left hand limit or left tailed, hence it will basically be consuming all the alpha value which is there. Still 1 minus alpha is to be covered onto the right hand side. Right hand side means this area. So, if you remember, this is the value which I am talking about, which this is z minus z alpha by 2, minus z being because it is symmetric one, obviously onto the left where I am pointing my left hand, it would be negative values, onto the right of the dotted vertical black line would be positive. So, based on that the alpha value is here and you basically do the problems accordingly. So, if you remember, the main task is basically beta is basically given as a fixed level and you are trying to basically minimize the or trying to find out the optimal value of alpha. Now, it is something to do with the hypothesis testing where it is on the right hand side. Again the concepts comes out to be same, I will highlight it. So, here mu naught H naught is case for when mu is equal to mu naught and HA, which is alternative hypothesis, is basically mu A is greater than mu naught. So, obviously, it will be the right hand side. Again be careful, it becomes that you will reject H naught if mu x bar n is greater than mu naught plus Z alpha in multiplied by sigma by square root of n, and obviously this Z alpha is not alpha by 2, it is coming for the case because you are considering the right hand side of the distribution, not the left hand side. Now, the actual case is coming where you are trying to test the case where under H naught mu is equal to mu naught and under HA mu is not equal to H naught, which means that you are do not know whether it is on the left hand side or the right hand side. So, now the actual essence of the interval estimation will be making sense. So, if you go to this diagram, so if just note the diagram, we have tried to make it as clear as possible. This is for the case when you are considering H naught is equal to mu naught, H naught is case when mu is equal to mu naught against HA where mu is A is not equal to mu naught. So, you are going to consider both on the sides, and if they are at the both sides, you will basically reject H naught if this is true. So, this being true, I will try to highlight it with the different color for the time being. Now, this is the mod. Now, if you basically expand and find out the mod, it is basically if it is on the left hand side or right hand side. So, left hand side means this one. So, this is where the highlighter is basically on the left hand side. So, again the same formula as for the left hand concept and the right hand concept which we just discussed, but only remember now Z is suffix alpha by 2 because you are equally proportioning the level of confidence in such a way the middle value is 1 minus alpha and the left value which is alpha is being equally distributed on the left hand side and the right hand side. We will continue discussing such topics in related to the mean value when standard deviation is known, then come to the case of the difference in the mean value when the standard deviations are known, when the difference of the mean values and the standard deviations are unknown, when we come to the ratios of the variances when the mean values are known, ratios of the variances when the population means are unknown, and continue that. So, we will see that we will cover both the Z distribution, T distribution with the certain degrees of freedom, pi square with the certain degrees of freedom, F distribution with certain degrees of freedom, and then move on to the concepts of more of design of experiments, and this would make sense that how we can basically understand and appreciate the concept which you are learning about hypothesis testing more in the design of experiments framework. So, with this I will end this lecture and wish you all a very happy day and stay well, and thank you very much.